Hi Expo, this is Mr. Monahan. This is the video for lesson 10.0a. We're going to simplify numerical radical expressions today. So that's the objective you'll write at the top. I will be able to simplify numerical radical expressions. The word radical, like we're going to define in a second, it just means square roots. So this chapter is about square roots, and we're going to look at how can we reduce square roots when they have variables in it or when they're just numbers. Today we're going to start with just numbers, no variables at all. So what is a radical? A radical is the symbol that is used to denote a square root, and it looks like this. Okay, I'm sure you've found it on your calculator before, and I know that we've used it this year to solve things. So radical is just another word for square root. We're going to talk about radical expressions. A radical expression is an expression that has variables and square roots. So it's combining both of them. So that's what this chapter is about. It's how to simplify those and reduce as much as possible. All right, let's keep looking here. If something is called a perfect square, what that means is we have something that is not a decimal when you evaluate it. So these are ones that can go right into the calculator. Square roots are what number times itself gives you the number under the radical, so the radicand. So the square root of 4 is just 2 because 2 times 2 is 4. So all of these are things that you do not get a decimal for, so we're able to evaluate the square root and write a number that doesn't have a square root over it, a radical over it. So the square root of 81, 9 times 9 is 81. Okay, the square root of 256, well, 16 times 16 is 256. 11 times 11 is 121. 18 times 18 is 324. 1 times 1 is 1. And then now we're into some more unique looking ones with square roots here and fractions. So this is a radical with a rational inside. So what you can do with something like this is you can just split up the square root. So you can do the square root of 64 up top, and you can do the square root of 81 on the bottom. So then we can evaluate those because those are perfect squares. So the square root of 64 is 8 because 8 times 8 is 64. The square root of 81 is 9. So this would just be 8 over 9, and that would be our answer. Okay, this one, 1 over 16, you can write it as square root of 1 over square root of 16, and that's just 1 over 4. Okay, square root of 1 is 1, the square root of 16 is 4. You can try the next one on your own. They're not any different. You can pause the video, give those a shot, and then hit play when you're done. So square root of 9 over 100, you can just write it as square root of 9 over square root of 100. And the square root of 9 is 3, where the square root of 100 is 10. So this just simplifies all the way down to 3 over 10. Okay, and then the last one, square root of 25 over 49. First step, split up the square roots. Second step, evaluate. Square root of 25 is 5. Square root of 49 is 7. Okay, unfortunately, we're not going to keep it that simple where we can just punch everything in. But if something is already a perfect square, that means it's not a decimal if you evaluate the square root. So those are the nice ones. You can just evaluate it and move on. Okay, let's look at if it's not something that's a perfect square. Okay, so to simplify non-perfect squares, okay, we need to try to think about what types of perfect squares fit into that specific number. So let me explain. Before we do that, you need to know at least your first 10 perfect squares. So the first 10 perfect squares, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, then 25, then 36, then 49, then 64, then 81, 10 squared is 100. Okay, so these are all numbers that if you take the square root, you get a whole number out. Okay, you could go a little bit further. 121 is the next one, then 144, then 169, then 196, then 225. That's the first 15. So now we have the first 15. Okay. So what we're going to start to try to do is we're going to try to reduce these non-perfect squares by finding something that is perfect that goes into it. So we're going to find the greatest perfect square that goes into the radical. Okay? If you take the square root of 24 in your calculator, you get a decimal. And this is just one of those times we're just going to say, you can't answer with a decimal during this chapter. It's got to be a simplified radical. And this is going to be something that we'll practice a lot. So the square root of 24, okay, is a decimal. It's almost 5, probably 4.9 or something like that. Okay, but what we can do, it has to do with what's up right here. Okay, you can, just like we did with the fraction, you can take a square root and you can split up a square root with multiplication. So I would look at the factors of 24, okay, and I would look to see, are any of the numbers in this list up here in red, are any of these numbers a factor of 24? And this time, 4 is. Okay, so what I can do is I can write this as, well, let me do this in a couple of steps here so it makes a little bit more sense. Okay, we can write this as the square root of 4 times 6. Okay, because 4 times 6 is 24. And then what we're able to do comes from right here. Since I can write this as the square root of 4 times 6, I can write this as the square root of 4 times the square root of 6. Okay, and since I know that the square root of 4 is 2, I can go one more step and I can write 2 square root of 6. And that is as simplified as we can get, because if you look at the square root of 6, the only factors are 1 and 6 and 2 and 3, and none of those are perfect squares. So I only want to look for perfect squares that go into these numbers. Okay, so let's look at 48. So for 48, your factors of 48 are 1 times 48, 2 times 24, 3 times 16, 4 times 12, and what am I missing? 6 times 8. Okay, I see a couple of perfect squares in here. I see 4, that's in this list right here, but I also see 16, that's in this list right here. So there's 2 ways I could split this up. How do I decide which one to do? Well, you want the biggest perfect square. You always want to get the biggest perfect square that can possibly go into that radical. So I'm going to choose the 3 and the 16 because 16 is the biggest perfect square that was a factor of 48. So I would write square root of 48 as the square root of 16 times 3. I'm just breaking up 48 into a pair of factors that make 48. Then one step to split up the square roots. That's the square root of 16 times the square root of 3. And now I'm at 4 square root of 3. And that's our most simplified version of the answer. Okay? Looking at 72, square root of 72, you can see that there's a little bit of a hint here. 9 times 8, 9 is a perfect square that goes into 72. 9 times 8 is 72. But there's actually a larger perfect square that goes into 72. If you look at this list up here, 36. 36 goes into 72 twice. So square root of 36 times 2. That's another way to write square root of 72, which is square root of 36 times square root of 2, which is 6 square root of 2. Okay? What if we didn't realize 36 went into it? Okay, let's take a look at that. Well, it's actually okay if you don't get the biggest. You just have some more steps. So we could write square root of 72. If we would have said 9 times 8 was the biggest we could find, 9 was the biggest perfect square we could find, well, then we would have 3 square root of 8. Okay, and those aren't the same. These answers don't match. Okay, but if you look at 8, 8 has a perfect square that goes into it, 4. So you could write this as square root of 4 times 2. All right, well, that is then 3 times the square root of 4 times the square root of 2, which is 3 times 2 square root of 2, but 3 times 2 is just 6. So you can see you can get the same answer, it just takes longer. That's why you always want to try to find the biggest perfect square that you possibly can. Okay, let's do square root of 90. We have square root of 9 times 10, right? Which is the square root of 9 times the square root of 10, which is 3 square root of 10. Okay, let's do the square root of 175. So the square root of 175, that's going to equal the square root of, well, let's think about what we can do. Okay, if you look up at this list, if you get something that ends in 5, it's a good idea to try 25 because that also ends in 5. So 25 does go into 175, and it's going to do that 7 times. So this is the square root of 25 times the square root of 7, and the square root of 25 is 5. And we look at the square root of 7, and that's a prime number. There's no perfect squares that go into 7, so we know that 25 was the biggest perfect square we could have had. Okay? And then let's look at 162. Sometimes you just have to keep looking at the list up top and seeing what works. When things are even, sometimes it's nice to divide them by 2. And if you divide 162 by 2, you get 81. And that's really helpful for what we want to try to do here. Because if I can write this as 81 times 2, well, 81 is a perfect square. So square root of 81 times square root of 2, and square root of 81 is 9. So this simplifies down to 9 square root of 2. So that's everything on that page. Why don't we go ahead and look at the next page, and I'm going to have you try a couple of the ones here that you should know how to do. There's 2 that I left out for now. And those have numbers in front. So why don't you pause the video, try these ones, and then we'll talk about the ones with numbers out front here at the end. Okay, go ahead and pause the video now. All right, you can check your own work. You should have tried those 4. 117 can break down into 9 times 13, and you can see the final answer there. 245 is 49 times 5. 150 is 25 times 6. And 63 is 9 times 7. So finding those perfect squares that go into the imperfect or non-perfect squares that are given. Okay, let's talk about what do you do with numbers out front. So if there's a number out front, you basically just want to leave it until the very last step. Okay, at first, okay, we're really going to ignore it. Simplify the square root first, then multiply the number in at the end. Okay, so that's really how we're going to approach this. We're going to leave it alone. We're just going to worry about the square root of 300 first. Okay, we're just going to bring this 2 along for the ride. So we're going to write this as 2 times the square root. We can break 300 into 100 times 3. Okay, and we can then break the 100 times 3 into 100 times 3. Square root of 100 times square root of 3. Then we can write that as 2 times the square root of 100 is 10 times the square root of 3. And this is where now we can do this 2 times 10. Okay, so we ignore it until the very end. We do 2 times 10 is 20. We leave the square root of 3 as it is, and that's how we would simplify that. Okay, so if there's a number out front, we ignore it until the very end. Okay, same thing with 216 right here. I think that's 36 and 6, if I'm not mistaken. Yep, so 216 and 6. Okay, there's like a -1 out front. We're just going to leave that alone for now. We're going to split the 216 into 36 times 6. Then we're going to split the square roots up. Square root of 36 times square root of 6. Okay, then we have negative square root of 6, or square root of 36 is 6, times square root of 6. And then this was just a -1 this time, so I don't need to take another step. But the last step would have been -1 times 6, which is -6. So if there's a number out front or a negative out front, just bring it along with you until the end. That's it for simplifying radicals that are numerical. So we didn't put any letters into it yet. That's what we'll look at doing tomorrow, and we'll see kind of how that goes. Thanks for watching. Have a great day.